Hi, good afternoon, everyone. I'm Beatin. I'm from Dow Chemical. First of all, thanks for attending my presentation today. On behalf of the other three co-colleagues, which is Dr. Sharon Wu, Dr. Han Tao, and Dr. Nina Nana Yu, I will be presenting Dow's new Nodal EPDM using advanced molecular catalyst for automotive weather strip application and TPV. Not used. Okay. In today's presentation, I will start to give you a brief introduction of Dow AMC, which is Advanced Molecular Catalyst Technology. Then I will follow by introducing Dow's new EPDM for weather strip application, which include the which include sponge weather strip, dense weather strip, corner molding, and also will also be giving you two grades, introduce you two grades of commercial Nodal EPDM, which you can use it for high hardness, high modulus profile. The last topic for today, I will give you a brief introduction of new high ultra molecular weight Nodal EPDM for TPV. Nodal EPDM was first produced by DuPont in 1963, and over the years we have been continued reinvent by developing new catalysts and also upgrading the technology. So if from this slide you can see that currently there's 3 generations of catalysts to produce EPDM I should say produce EPDM now. So for currently 75% of EPDM produced globally is using Zinanata, which is a low, and Zinanata's catalyst is actually a very mature technology, and it can produce a wide variety of EPDM. But it is a low efficiency catalyst, and it needs to be de-aging. It needs to go through a de-aging steps to remove the residual catalyst, which is metal like irons, aluminum, and titanium, which means that it needs a lot of energy for this to produce this EPDM. During the 1990s, Dow actually come out with the first generation metallocene EPDM. And the metallocene EPDM is highly efficiency. 1 gram is 10 times more efficiency than Zinanata. 1 gram of the catalyst can make about 1 metric tons of the polymer, which means that it do not need to do these descaling steps, and which naturally make the product low gel water white EPDM. And because it do not need to go through the de-aging requirement, it actually is more energy efficiency than Zinanata. So even at this day, metallocene catalyst EPDM is still more efficient, still the most efficiency plant in the world. During the 21st century, Dow actually invented a new forms of advanced molecular catalyst. We call it AMC. This is a very complex, more complex catalyst, which is ultra high efficiency. It can allow the catalyst allow us to tailor design the EPDM architecture, molecular architecture. So which means that we can control the composition and also the molecular weight distribution of the EPDM, which means that it allows us the technology actually allows us to have broader molecular weight and so-called ultra high molecular weight. It also allows us to have increase it allows the EPDM to have higher filler acceptance due to the high molecular weight. It also, the technology also allows us to have higher EMB, which means faster cure for the EPDM. So this new AMC technology actually helps to expand our portfolio and capability. Okay, I'll go to sponge gate 6. As you know, for weather strip, it's a complex. A weather strip for automotive, it can be a door seal, it can be a glass corner channel, it can be a corner molded. And door seal is the most complex one because it consists of a low density sponge foam coax with a dense metal carrier. So we have actually developed a new grade called 6555 OE, which is targeted for sponge weather strip. As you show in this chart, 65555. Sorry, 65555 is a high dying atmosphere EPDM grade, which is the and it also have 23 parts. Oh, sorry, it have 23 parts of oil, 8.5 EMB, and most important thing, it have high long change branching. So as you compare to a 2-branch mount EPDM that is used for sponge grade, you can see from the melt elasticity comparison chart. The melt elasticity of this Nordel 6555 is very compatible to incumbent benchmark EPDM, which means that this product can give a more a collapse resistance sponge foams. So this polymer actually also have high polymer viscosity, high branching, as I mentioned, and it provides a balance of processing, extensibility, and also fast curing due to the 8.5% EMB. The 23 parts of oil actually allows convenience of mixing for the customers. We Downs have developed a comprehensive technical package, which include a 1-pass mixing, a 2-pass mixing for customers which is currently unable to do 1-pass mixing, and also a troubleshooting guide. Okay, this is the formulation that we use. A formulation that we use for the development. We actually blend the. Okay, this is using what we do is we blend using a 135 liters intermeshing mixer, and upside down mixing techniques are recommended, which means that you add oil filler first before you add the EPDM. It's a 1-pass mixing. It allows, because of the presence of the oil in the EPDM, which means that the viscosity of the compound is medium in terms of viscosity, which allows you to have fast mixing and homogeneous mixing. And the formulation is developed in a way that it will not have, when you're compounding the time, it will not generate too high in temperature that cause premature curing or decomposition of the foaming agent. In the formulation, we also have a slight amount of a very slight amount of TDEC in the formulation. This is to allow fast curing of the skin. When the profile is extruded out, going into the oven, it will cause fast curing to form a thin layer of skin, which allows when the profile to be non-tacky during the continuous vulcanization process, and also allows to have low water absorption during use of the sponge. So for this formulation, for 1 pass, we're able to get less than 5 minutes of cycle time, and we dump the compound at 95 degrees. Okay, this chart actually show, okay, the table here actually show you the sequence of the ingredient during compounding, and the graph is actually showing you the batch temperature, the energy input, the RPM, and also the ramp position during the mixing cycle. One thing I wanted to keep in attention that during the addition of the curative, we actually reduce the RPM, rotor RPM from 45 to 15, so that to ensure that there's no heat, the temperature of the compounds don't heat up too high to avoid scorching. After drop off after the compound drop from mixer, we actually go into 2-roll mill to make into strip. Then the next step will be going to the extruder. Okay, this is we are actually during the experiment, we actually use a weather strip line, and this is how it looks like. The extruder is using a David standard single screw extruder of 90 mm and at a speed of 19 RPM, and the setting temperature is shown in the table. Okay. After that, after extrusion, we actually go into a continuous going to a 20-foot oven. The first 2 oven is hot air oven, where we can control the velocity of the air. We can control the temperature and speed and the speed, line speed. So for the microwave oven, we can actually control. There's 3 different control on the power, but this is how it looks like. So from the graph, you can the table 1 actually shows you the physical property of the foams, of the sponge foam that I show that we use using a single pass mixing. The condition using this just now I showed it to you. You can see that we can able to get a very good low moisture, water moisture of 0.26 and a good compression set at the target density of 0.66. And on top of that, we can see that we have very good, a much better tear strength and tensile strength as per normally required. We also examine we actually also extrude the foams, and look, you can also see that the foam have very uniform cell structure, and the surface and the appearance is very good. Okay, as just now I mentioned, we have Dow actually have developed a very comprehensive technical guide, which include a 1-pass and 2-pass solution, mean safe cure system, we also have a guide on troubleshooting to teach you how to meet target density, how to improve the profile smoothness, surface smoothness, how to control the cell content and lower water absorption, and how to improve the compression set. If you're interested, please contact me. We can discuss further. Okay, then the next steps. I will talk about the grade that we developed for dense weather strip, or it can also use for dense profile. As you can see from the table, Dondel 6565 is a high dying amorphous EPDM grade designed for extruded application that require fast curing and rapid property build up. 6565 actually, if you compare to Nordel 5565, which is using an old generation metallocene catalyst, you can see that the EMB of 6565 is 8.5. It's much higher than the 5565, which means that, as you can see from this graph, the higher the EMB, the faster the cure rate. So, and 6565 is also designed to have a medium polymer viscosity, broader molecular weight distribution, and higher branching rheology, so that it will allow you than the previous generation. This is to allow you to have a balance in terms of processability, extensibility, and low temperature requirement. Okay, the graph I'm showing here, this is the first weather strip that using 100% of Dow's products. We have a customers in Europe, which is the biggest weather strip producer, and they have actually used it, and they actually like it. You can see the lower one is using incumbent EPDM. The top one is using the foam itself. The sponge foams is actually using 6555, and the dense part is actually using 6565. Okay. The next, the last weather. The next topic I'm going to talk is about 6530. This is for corner design for corner molding for weather strip. Okay. Sorry. Okay. Okay. 6530s are designed for fast curing, injection, and transfer moldings. For transfer molding, it got very high unsaturation of 8.5 EMB. It got its atmospheres, and it is the low viscosity of 30. So, which allow high fluidity. You can see from the GPC graph here, green color is actually 6530. You can see that the molecular weight distribution is much broader than a metallocene, metallocene EPDM grade, and also a Zinanata EPDM grade. So this will mean that it actually have excellent processability and elasticity for both low and high temperature requirement. This is actually, as I repeat again, this is actually more for corner molding, belts, and molded parts. Okay. The next two slides, I will talk about two commercial grades for high hardness, high module profile. Okay, 4725 is semi-crystalline EPDM with and Nodal 4820 are crystalline EPDM. Both of them have 4.9% of EMB. The one in the graph we show VEPDM. This is a popular grade for high modules, high harness profile, which is already terminate. So as you can see, what we do is that we actually do a comparison test, comparing the VEPDM with 4725 and the blend of 4725 with 4820, with everything remain the same. Okay, this is the results. The table actually shows you that as compared to VEPDM, 4725 and blend of 4725 and 4820, you can actually have a better elongation and compression set at similar hardness. So this means that 4725 or a blend of 4725 for 4820 allow you to have high hardness, high profile, high hardness, high modulus profile with good properties. Okay. Now I will go talk to the last topic of my presentation for today. This is a new ultra high molecular weight Nodal EPDM that Dow developed for TPV. This high molecular weight EPDM have 60 mono viscosity, 65% of ethylene content, and 4.5 of EMB. And important thing is have 75 parts of oil, which allow for better compounding and better branding. And this is also is actually designed for premium TPV. We actually do make a TPV product using our new ultra high molecular weight EPDM, and you can see that the properties is comparable to premium types of TPV. The important thing is that we actually extrude out a tape, and you can see we can see that the surface is of the extruded tape is very smooth. And if you look at using an ANF test, the morphology of the TPV, you can see that the rubber distribution the rubber particle size is very small. It's less than 2 microns, and it's well distributed in the PP metric. This is my slide. Just to summarize what I have just now said. Now, new AMC technologies has enabled next generation of metallocene EPDM that give excellent sponge weather strip with superior surface and physical property. The Nordel 6555 OE have better processability and process control consistency for automotive sponge profile production. Nordel 6565 XFC enable fast extrusion and fast cure suitable for solid and foam extruded profile for Class A surface. We also have a new ultra high molecular weight Nordel, which EPDM for TPV, addressing industrial needs with tailored architecture and rheology. This ultra high molecular weight is for better morphology development and mechanical property. And the composition is tailored for a better balance of property. And this new grade have 43% or 75 parts of oil in it for balanced throughputs and formulation flexibility. That's all for my today's presentation. Thanks for your attention.